Hello, everyone, and welcome to another episode of Innovation Saves Lives with your host, Leonard Kim. And today we have Yoni Kalin over at Plant Cell Technology Inc. And if we kind of think about how the world's been set up, you have a lot of free radicals everywhere. There's a lot of pollution. There's a lot of things going on. And what Yoni is doing in the back end is he's like the invisible infrastructure that labs rely on to really grow this new cell culture that's going on. Because if you think about it, everything happens at the cellular level. But I'm not a scientist, and Yoni probably is. So let's go into more detail about exactly how you got started into this industry, what it's all about, and what gets you so excited about it.
Absolutely. Well, first off, Leonard, thank you for having me.
Of course.
Quick correction, I myself am not a scientist.
Okay.
Fortunately, I work with a lot of scientists that are way smarter than me. So kind of my mantra is putting myself in a room with people smarter than me, and that's how I grow. But I really fell in love with the science about 7, 8 years ago.
Nice.
I did a kind of deep dive into cell culture right around the time the hemp bill was passed. So believe it or not, there are a number of diseases, viruses, viroids that infect a number of plants, whether it be tobacco, cannabis, corn, bananas. And one of those viruses, viroids, actually jumped from, I believe, tobacco and or lettuce and now infected the cannabis crop. And so I started to do a little bit more deep diving into how and why those viruses spread, but also where at the cellular level plant nurseries and farms, how do they remediate that, right? When you fly to different countries, your customs agents are worried about you bringing crops in, right? Because those crops bring diseases.
Yeah.
So for me, the science was fascinating, and then the business opportunity even more so, right? The more I learned about what tissue culture and cell culture technology could do for the industry, both when it comes to food resilience, developing medicines, developing vaccines, actually preserving genetics, preserving the Earth species at a very high level, I kind of fell in love with the industry and joined Plant Cell Technology. Fast forward 7 years later, as you aptly described, what we do at the core is PCT operates at the invisible infrastructure layer of biotech. So we manufacture the consumables, the systems, and we provide the knowledge that labs rely on to scale cell culture reliably. So the main focus, the way that we do that is by eliminating the three main failure points in biotechnology. The first being contamination, the second being inconsistent product, and the third being a lot of manual labor. So these are the three pain points that prevent biology to scale.
Yeah. So when we kind of rewind back at the time 7 years ago when you were discovering this, when you were looking at the hemp and the things that went from tobacco into other things to kind of contaminate them, what were you doing back then?
So I was working in international trade compliance.
I see. That's
A completely different industry.
Yeah.
But the way it ties in is a lot of our business, we do a lot of international business. So we're working with every continent around the world, 80 plus countries, and we service various markets. So part of the background that I brought through business development and international trade allowed me to better understand the landscape of how chemicals move between countries, import and export regulations. I won't get into the weeds of that specifically, but to tie back the viroid and viruses that are spreading across plant species, what I learned is plant tissue culture is one of the mechanisms that we can clean plants without using pesticides and herbicides. So instead of a traditional method of spraying a plant with said herbicide, we can actually go to the cellular level. We can take stem cells from that plant and we can regrow that plant at scale. So let's say you had the most valuable blueberry, you know, the blueberry that you buy at your grocery store. It's the most delicious. It's what your customers have grown to understand and rely on. If that blueberry gets some disease or virus or viroid that you can't cure, bye-bye blueberry. But what tissue culture enables us to do is actually back up those genetics. Similar to backing up your data on the cloud, we can back up genetics on the cellular level, create and store millions of the same plant species at scale in a small amount of space. So whereas a farm, you might need 10x the amount of space to store a million clones. With a tissue culture lab, you need about 1/10 of that space.
Oh,
So
wow.
the implications of what we can do on the cellular level enables us to really control how we grow food, how we distribute food, and how we preserve the world's genetics despite some of the climate change and risks that we're facing today.
One of the interesting things that happened last year is when I went down to Temecula, which is in Southern California, I was going to a bunch of wineries, and everyone down there is always looking for a way to go and be pesticide free and so forth. And one of them decided to kind of go all the way to that level. But then next thing you know, the locusts came in and ate all the crops. And then another group, they went close to that, but then they kept one of the pesticides in. So they were almost organic, but then they made sure to put that one thing in there. So it's kind of interesting when you kind of think about it, because this one thing could really just cause so much turmoil in the world of plants and so forth. And when you kind of think about viruses as well in the world of plants, I mean, that could have a major effect, especially if you're transporting plants from one country to another. What are some of the steps that you're really taking to really go out there and prevent that virology from happening?
So the good news is there are methodologies to prevent those plants from dying. The bad news is we're focused on upstream. So we're at the very beginning of the process. And what I mean by that is we're supplying the nurseries or the growers that are eventually providing to those farms. And what we do is ensure that those nurseries, those growers, those institutions are growing clean, healthy plants. Which then can deliver to the farms. Unfortunately, we don't have the tools and systems to prevent the pests and locusts from killing those plants in the fields. However, this might be a 20, 30, 40-year vision, but my thinking and understanding is, unfortunately, with climate change, farms will become more and more obsolete. What I mean by that is very high heats, very freezing temperatures will make it harder and harder for us to grow crops outside. Tissue culture plus nurseries and indoor farming is kind of the salve for that situation, and more or less how I believe we're going to be sustaining agriculture at a global level. I hope that doesn't happen, right? I hope we can continue to have farms. Farmers are the most important workers in our society. Agriculture is what sustains us. It's what builds us. With that being said, I'm preparing for the future, and I see tissue culture as one of those methods that enables us to continue to grow at a large scale and supply more efficiently. So one interesting thing when it comes to shipping internationally, and this ties back to the trade compliance, there are much more lenient regulations around shipping a plant in a test tube, and I'll tell you why. That plant is certified sterile. There's no contamination, there's no bacteria, there's no disease that could spread to, let's say, the US ag market if I'm importing from Thailand or Vietnam. And with a phytosanitary certificate, I have an easier time to import these plants. Not only do I have an easier time to import them, but they have a much higher likelihood of surviving in that test tube because they have water, they have the food, they have the nutrients they need to survive. Whereas if I'm shipping in soil, you might not water it for 2 weeks because it's stuck in customs. So plant tissue culture has also created a very interesting avenue for growers to export plants without some of the customs restrictions. So we see a huge market developing, especially around the boutique and plant collector market, primarily house plants, orchids, variegated plants. But a sizable market continues to grow where people are shipping plants around the world, cloning those plants, and really creating a whole economy around plant love, and tissue culture is the basis of that. So we're really into the ground floor, and I like to call us we're the power grid. We're the grid that powers we're the grid that powers the industry via infrastructure, via consumables, via education.
Nice. Yeah, it's kind of interesting for the plant collectibles. Like, I browsed around in those communities because I have friends who collect them. Like, oh, you just spent $100 on a plant, $500. It looks pretty
Try
silly.
$10,000. I mean, there's some hobbyists that'll spend $10,000, $15,000 on a single plant. Can you
And
imagine?
then like there's even those farms out there who are growing like the $20 strawberries that you could get at the grocery
Mm-hmm.
store for the single one. And if you really think
Mm-hmm.
about it, if you have that condensed space and that controlled environment, you can really go out there and create a lot of these in controlled environments where you're able to kind of maximize off those returns and also save some of those endangered species, which are a lot more difficult for a lot of collectors to get their hands on. And I think that's a pretty interesting thing, especially if you have that type of environment where you're starting at the very beginning and being able to raise things off and ship them anywhere. Because I think one of the biggest challenges is like, what if you can't get to the plant for 2 weeks? What if it doesn't get any water? Like, what happens then? Like, it's not really a good thing for that plant.
In soil, it'll die. In tissue culture, it'll survive. We've had plants in our lab that have been in culture for almost 2 years, 3 years.
Oh, wow.
Why? Because they have the media they need to survive. They have the nutrients. They have the humidity. Whereas soil, you have to basically take care of that plant consistently. In tissue culture, you have to subculture it depending on how fast it grows. But we have methods and certain ways of preserving those plants, right? Slowing down their growth rates, cryopreserving them, where you can have a species in tissue culture for 5 years if you wanted to.
Oh, wow.
And that's what enables us to really create a more effective distribution system and growth system of how we can grow food, right? It doesn't have to be harvested immediately.
Yeah.
We can delay it, or we could back it up, just like we would back up our genetics. Let's say you're a strawberry grower and you want to cycle out one flavor of strawberries. Instead of killing that crop and having to use seeds to find it again, you just take a cutting, you clone it, you back it up, you put it in a growth medium that might be a little slower so the plant doesn't grow as fast, meaning you don't have to dedicate as much labor to maintaining it. And then, hey, come 2-3 years, you want to reintroduce that plant back, that's what you can do. We're saving time and money. Growers are pheno-hunting, they're testing different seeds, they're trying to find the next best thing, where instead we can just preserve what we already have and then rotate it. Be more strategic about how we introduce these foods and when.
That's kind of crazy. Yeah. And I was speaking with someone about a week ago on this podcast, and he was talking about like the embryo of an animal. You could freeze that, and for like years upon years afterwards, you could put it into another animal, and then it could grow into a full-blown baby. So he was saying that's a lot similar to like the IVF process, where women would freeze their eggs and they were able to get that to reenact and have a baby as well. And from the surface, it sounds like the science behind what you're doing on a plant level is kind of similar to this.
I'm glad you brought that up. So, we really started in the plant space. And what I'd like to say, plant systems are the most scalable, right?
Yeah.
It's a forgiving environment. You can build and prove the infrastructure without as much risk. And the thing is, with plants and also mammalian cells and human cells, if you can make biology predictable, then the principles can translate cleanly into more sensitive systems. So mastering the plant infrastructure has enabled us to then pivot now into the mammalian space. And what's beautiful about mammalian cells, so for context, in May we bought a competitor of ours. We bought their factory, their infrastructure, their IP, and we kind of dove headfirst into the mammalian space. And mammalian culture covers animals and humans, and then we also have like insect cells in there as well, which is interesting. But what I'm learning, I'm not an expert in it yet, but mammalian cell culture is really the basis of how we develop a lot of our scientific research around medicines, around vaccines, and around treatments.
Yeah.
I mean, when you're working in a petri dish, you're working with animal cells and you're seeing how diseases react to those animal cells. And another positive implication of animal cell culture is instead of testing on live animals, we can test on their cells. So it's a little bit more ethical, I'd say. So instead of testing on a green monkey, we have something called Vero cells, green African monkey cells that we test. And we have all different medias that we use to grow those cells, and then our customers have a variety of applications. So we ourselves are not the headline therapeutics. We're not developing the stem cell research per se, but we're the powering layer for those researchers. We're providing them the infrastructure, the consumables, the equipment that they need to be successful. And the most exciting part for me is I don't have to bet on one horse.
Yeah.
right? I can be involved in mammalian cell culture. I can touch plant cells. I can touch insect cells. I have, not I, plant cell has, our reach is broadened and diversified. And so the same failure points that you see in biotechnology, specifically around plant cell culture, carries over into mammalian cell culture. And so we are building on that infrastructure to optimize not only how our plant customers grow at scale, but then, pivoting to the mammalian side as well, which is, albeit a much more regulated industry, a much larger industry. And, there's I need to read a lot more books before I speak specifically on the mammalian side. But I do have some amazing scientists on my team that are experts in it, and they teach me more and more every day. So I try to consume as much as I can and focus on the business development side and the strategy. Like, how do we push forward? What do scientists need from us? And we execute from there. It was a long-winded answer to your question, though.
That's a really interesting look into the far future of where you're heading and where you could end up becoming. But when we kind of bring things back to more recently and kind of in today's area, a lot of people come to your company for multiple reasons. Can you kind of explain what they are?
Sure. So I talked a little bit about the infrastructure. I think another metaphor I'd like to use, or another terminology, is we built an ecosystem, right? Mm-hmm. Our ecosystem and our operating platform enables anyone from a hobbyist to an institutional researcher to be successful in cell culture. For example, when it comes to plant tissue culture specifically, we sell to companies like Driscoll's, who develop the fruits, the strawberries, blueberries, blackberries, raspberries that you buy in the grocery store, whether it be August, September, June, July, February. You're able to buy blackberries. Why? Because they're clones. Yeah. And they're most likely coming from tissue culture at one point or another. The hobbyist side, we've developed a series of educational videos, classes, and training models to enable hobbyists that might not be able to afford the same lab as a Driscoll's to still be successful at tissue culture. So as we alluded to or mentioned earlier, there's a whole market around houseplants, variegated plants, orchids. We're teaching plant lovers how to not only clone their favorite plants, but actually do them at a larger scale. So if you go to let's say a plant store and you find a Monstera deliciosa and it's going to cost you $45, we'll teach you how to grow 1,000.
Oh, wow.
Right? Traditional methods, you take a, snip, you take a cut, you might get 2 plants from that. With our method, you're getting 500, 1,000, depending on the scale. And so we're able to take a technology that's been very much controlled, if you will, by a select group of the science community and provide that education and infrastructure to the hobbyists that may not have that training, but can develop it. And plants, the best part about plants is plants are the gateway into cell culture research. Yeah. Now, what I believe and what I'm passionate about specifically around education is, in order to learn about cell culture, you need to go to a university. And you have to spend $250,000, $300,000, $400,000 on an education, study biology, botany, bioengineering, and then you may or may not get a couple hours in the lab per semester. What we've done is we've created a trade school model for hobbyists specifically, or growers that are looking to refine their skills, optimize the way that they conduct and produce plants at scale. And through this model, we're able to not only introduce people into the cell culture industry via plants, but really gain more interest into this industry, right? We're trying to grow the industry as a whole, because my feeling is the more scientists that we have dedicated to this, interested in this, the better research that we're going to have down the line. We're going to develop medicines faster. We're going to have better food resilience down the line. We're going to be able to preserve more of the world's most endangered species, because we're creating scientists that care, scientists that are focused on caretaking the world's species. So I like to call our growers caretakers. Nice. Where most institutions or university research around cell culture, they're focused on one of 3 crops: soy, corn, tobacco, right?
Sounds like America.
Yeah, sounds like America, but what about orchids? Or what about carnivorous plants that were near extinct? What about certain types of variegated Monstera deliciosa species that might not have food value, but they're beautiful and they might benefit the ecosystem? So we are introducing the science, making people hopefully fall in love with it, and then creating caretakers within a broad variety of species that universities might not focus on. So whereas, corn, soy, and tobacco might live forever, we want other plant species to live forever. We want other house plants and carnivorous plants and flower species that are imperative and part of that ecosystem to survive. And via the knowledge that we're sharing and hopefully the passion we're creating in the next generation of scientists, we're doing just that.
I think that's really cool. So let's say I have a hobby, I have 300 extra square feet around that I could probably set up a shed or something. I love this specific plant. I'm super passionate about it. I could get involved with these training programs, learn more about it, order these, and next thing you know, I have a business and I'm doing something I love with an endangered plant or something that really matters to me. And I think if you think about it from the hobbyist standpoint, once they catch on about this, like this could really turn into something that's super exciting for them to do that they share, and then a lot of these species could be like reintroduced to America and across the world. Because I mean, like, while tobacco, corn, and soybeans are important, like there's the other things too, right?
Absolutely.
Yeah.
Absolutely. And to that point, I mean, we have a number of students that have taken our class that are now growing very, very profitable businesses, and growing substantially because there's demand. People love plants. People want to learn and people want to buy it. So there's this niche economy growing from the hobbyist side. And then at the same time, you have institutions using the same supplies to grow millions of plants at scale. So it's beautiful how this industry has really started in a very small subsegment with the orchid industry, eventually grew to the larger agriculture, forestry, horticulture side. And now we're seeing an emergence, I'd say probably around COVID, when we started doing YouTube videos and intros. There's this hobbyist market, right? People were learning how to make bread. People were learning and dancing on TikTok. And then people were growing plant cells in home labs. And so I'd like to think we're behind a lot of that. And there's some amazing influencers that have kind of popped up over the years. And so it's growing and we love to see it. So,
Nice.
a rising tide lifts all boats in the science. It's the way I look at it.
Yeah, and I think it can help other people who are like farmers as well. A few years ago, there was a tariff increase that wasn't as public as the announcements recently. And back then, there was no tung oil that was being produced in America. This Chinese lady went out there and convinced some farmers to go out there and grow tung trees to start to create this oil here. And just due to the tariffs and the spread, they made a pretty good amount of money from it. So even by going out there and finding existing crops that might be available in other countries, if people really put their mind to it, and if they have that crop size, maybe they could pull out a more profitable crop, especially if you look at today's landscape with how much of those increasing tariffs are around now.
And that's exactly the next layer of where we're going here. I use the term hyper-localizing, but we're seeing more and more countries want to create their own biotechnology infrastructure because food dependency on one or two or three countries globally is dangerous.
It is.
Right? With tariffs, with potential trade wars, with uncertainty in the globe, more and more countries want to develop infrastructure to provide food at scale to their populations. Now, there's always going to be opportunity costs or competitive advantages. However, tissue culture is scalable. And with the right labor and the right infrastructure, you can grow millions and millions and millions of plants. That can be, they go from the lab to the nursery to the farm. And we're seeing that happen globally. As I mentioned earlier, we supply most countries around the world. And more and more of these countries are interested in the education. They're interested in building local centers for food production. And there's also opportunities, right? So instead of importing wheat from Ukraine, you might be able to import from a country much closer, or Iowa, or and so the food resilience and supply chain shock that happens with uncertainty around the globe can be alleviated by more localized production, more localized development and research. And so it's just a matter of time where more and more countries will take the initiative and or invest in improving their infrastructure for local production.
I can see that,
And I
it's
think they
kind of
should.
interesting. Yeah, I think they should too. And it's kind of interesting, even if you go to a grocery store as a consumer and you just randomly just start reading the labels one day, you're like, oh wow, this orange came from Mexico, this grape came from Peru, this garlic came from China, and you're like, what? All this stuff came from all these different places. So if we kind of think about it, we're getting things all from all across the country, but if we could develop these things in our own backyard, that could be pretty powerful.
To an extent, right?
Yeah.
There's always going to be international trade, and we don't want to change that. International
Yeah.
trade is beautiful. It's what connects the world.
I
At
mean,
the
at a
same
hobbyist
time,
level. At a hobbyist
yeah, I
level,
mean,
if
at a
you're growing
hobbyist
in your
level,
backyard,
but
it's like crazy. It's like, wow, it's all right here.
reducing dependency
Yeah.
is, I think, what will strategically provide better layers or better infrastructure for countries to support their populations. And the United States is really leading the charge. I'd say South America and Asia are right there with it. Europe has some of the most brilliant minds in tissue culture and food science, specifically around automation, robotics. So there's a lot of things happening in the industry. I particularly am more passionate about plants because, number one, I love plants. Number two, we don't have an earth without plants.
That's true.
And everything we're doing, I think, has a positive impact in the long run in providing that food security that we need. Because we don't know how the climate will change. We don't know if we're going to be able to grow corn outside. We just don't know what it's going to look like in 20, 30 years.
We don't. I was
For
out
better or for worse.
today. I was out today. It's January in California, and I'm like, wow, it's just so warm and hot today. And I was over in Palm Springs like during Christmas, and during that time, you usually see snow on the mountains. There wasn't really anything. I mean, it did rain while I was there, then it started covering everything. But right before that, there was like nothing. So the seasons are like slowly shifting, and things are warmer. Well, what could that do in 20, 30, 40 years? Could what you're doing prevent a lot of the problems for it? It's a good question to have, and I mean, what you're doing could be a really good thing.
I hope so.
Yeah.
Well, I hope we have the solutions. I don't
Yeah.
hope the world changes in that way.
Yeah,
I think
true.
it's more about preparing strategically and think about it. How are we going to grow plants in space? Tissue culture.
Yeah.
That's the basis for how we're what we're looking into. But that's a little out there.
So the next steps to figure out how to get things into Mars and other places. It's about a time when we're about to end our show. Were there any final thoughts that you wanted to leave with our audience?
I think the big thing is open your mind, look into something like plant tissue culture that may have not been on your radar, and you'll be surprised at how integral it is into our economy, our food system, the way that we develop the future of medicine, and hopefully we can teach you if you're interested. We have classes, we have starter kits. You can reach out to our team if you want to learn more, but this science is imperative and it's going to change the world, and it's going to help us, I think, help the human race continue on for a very long time, I hope.
I think what you're doing is amazing. First, by being able to go out there and create this technology that's going to help plants survive for such a long period of time. And two, for creating teaching materials so people can learn more about how to take advantage of this from any level, even if they have no formal education in it at all. If anyone out there is listening and they want to get involved in this, go to plantcelltechnology.com. This is Yoni Kalin, the founder of Plant Cell Technology, and your host, Leonard Kim. This is Innovation Saves Lives, and we'll see you next time. Thank you.